to lesson 4.7. Today we're going to look at stoichiometry of precipitation reactions. So the first thing we're going to do is we will look, when you're solving a problem like this, you look at the species present and determine what reaction occurs. When we're going to look at the net ionic equation for that reaction, so you have to go through the steps of figuring out the complete reaction and work down to the net ionic equation. Calculate the moles of reactants, determine which reactant is limiting, calculate the moles of product, and then you convert to grams or other units as required. What if all ionic solids were soluble in water? How would this affect stoichiometry calculations for reactions in aqueous solution? This is actually an important question, because if all ionic compounds were soluble in water, it'd be very hard to do a stoichiometry reaction, because generally you need to figure out what percentage of product you get, and if you can't determine the mass of the product, then it's hard to determine that. So the only way to determine the mass would be to drive off all the aqueous solution, and when you did that, you would get both, you would get all kinds of ionic compounds in solution. So the rest of the slides in this PowerPoint run through an example. When aqueous solutions of sodium sulfate and lead 2 nitrate, are mixed, lead 2 sulfate precipitates. Calculate the mass of lead 2 sulfate formed when 1.25 liters of 0.05 molar of lead 2 sulfate and 2 liters of 0.025 molar sodium sulfate are mixed. Define the mass. So where are we going? We need to find the mass of solid lead 2 sulfate formed. What do we know? We know what we mixed. We also know the chemical reaction. What information do we need? We need to know which one of those is limiting. So how do we get there? What are the ions present in the combined solution? So when we mix the sodium sulfate and the lead 2 nitrate together, those are our ions. Since sodium nitrate is soluble and lead 2 sulfate is insoluble, solid lead 2 sulfate will form. So what's the balanced net ionic equation? So it's a 1 to 1 to 1. What are the moles of reactants present? So in this particular case, we had molar solutions, or we had solutions with a molarity. And so we can take those solutions and we can, this is the molarity of that lead solution right there. And so in that particular solution, all we have to do is take that molarity times our volume, and then we end up with that many moles of lead. Same kind of thing we do with the sulfate solution. There's our molarity in the box. Take it times our volume, and that's how many moles of sulfate. Since this is a 1-to-1 reaction, we know right off the bat that this one's limiting because I have less moles of it. So how many moles of lead sulfate can be formed? Well, we have to use the limiting reactant. And so the limiting reactant, we have 0.05 moles of lead sulfate, because in our reaction it was 1 to 1 to 1. So that means if I have, this was our limiting, I had 0.05 moles of that. So it reacted with 0.05 moles of that to make 0.05 moles of that. So that's why I can start off over here saying I have 0.05 moles of lead sulfate. I take that times the molar mass of lead sulfate, and I should obtain, after drying, 15.2 grams of lead 2 sulfate. So that was kind of a quick run through, but you notice how super nice it is when you are dealing with molarities, because up until that last slide, we didn't have to calculate a molar mass to get our moles. So that concludes lesson 4.7. Next time we're going to look at acid-base reactions.